Here we have another example for the projectile motion with an object that is ejected from an elevation. An object is ejected from an elevation as shown in the figure. Determine the value of the gravitational acceleration given the following values. Height of the projectile from the ground 0.8 meter. Time for the projectile to reach the ground is 0.41 seconds. To determine the value of gravitation acceleration, we examine the condition of the setup. It starts at the top with an initial velocity but launched horizontally, which suggests it has no vertical component. This suggests we need to select an expression that fits the situation. Here we have 6 equations that describe motion in 2 dimensions. We see that equations 3, 5, and 6 have the unknown variable. However, equations 3 and 6 would require us to determine first final velocity. Using equation 5, we determine the value of the acceleration due to gravity as shown here. Looking at the figure, we then substitute the known values to equation 5. Here we simplify the equation by rewriting it to solve for the parameter for the gravitational acceleration. Substituting the known values, we have the value of the gravitational acceleration to be about 9.52 meter per second squared. This value is close to the value we usually indicate for gravitational acceleration, which is 9.8 meter per second squared. Let us determine the initial velocity of the projectile given the distance 1.26 meters along the horizontal dot. To find the initial velocity, we recall the Pythagorean theorem as shown here in equation 7 and 8. For the initial velocity, it is easier because it has only the x component, which we can determine using equation 2. We then substitute the known values after rewriting the equation 2. We see that the initial x component is about 3 meters per second. Using Pythagorean theorem, we see that the initial velocity to be about 3.1 meter per second also. This is due to the fact the projectile is launched with only an x component. So the initial velocity is given as 3.1 meter per second along the positive x-axis. Now, let us determine the final velocity of the projectile before it hits the ground. Velocity along x is constant, which is a condition where we ignore air resistance, thus having a constant acceleration of 0 along the x-axis. To solve for the final velocity, we need to find the value of the velocity along the y-axis. To solve for the velocity along the y-axis before the projectile hits the surface, we determine it using the equations of motion. We do not need equations 1 and 2 since they are on the x-axis. Among the equations along the y-axis, equation 3 seems the much simpler equation with our available given and solved values. You can use any of the equations along the y-axis since the parameters are available. Substituting the known values, we have the velocity along the y-axis to be about negative 4.12 meter per second. Then using the Pythagorean theorem, we determine the magnitude of the velocity to be about 5 meters per second. Next we identify the direction theta of the projectile. To determine the direction, we use the tangent function as shown here in equation 8. Substituting the known values, we have the value of theta to be about 53 degrees with respect to the positive x-axis. So, the final velocity of the projectile before it hits the surface is given as 5.15 meter per second, and 53.04 degrees with respect to the positive x-axis.